Greetings, student. This is a recording of one of Garnett's online math lesson classes. You have been granted access to watch this video because you're a paying student and I have seen it fit to provide this recording to you. However, it is important that you know you're not allowed to share this video with persons outside the lessons. This policy is so that my services are kept only to my students. Thank you, and I do hope you enjoy and learn from this video.
Good afternoon once again, young mathematicians. And last class we left off looking at factorization. I explained what factorization is. I went into detail on what are factors and how to identify them, how to identify individual factors in a problem. One of the first methods of factorization we looked at is factorizing using the highest common factor and distributive law. And the reason why we did this one first is because fundamentally the other methods comes back to knowing this, right? Knowing how to use the highest, identify the highest common factor and the distributive law, right? We went through some problems. Yeah, I explained the distributive law to you. Yeah, I explained the distributive law to you, which is basically opening up your brackets. And of course, this is math, so you gotta be able to go in both directions. And factorization is the reverse of the distributive law. So this opening out your bracket, if you wanted to go backwards, you would have to identify the factors of 12 and we'd have to factorize 12 and 21.
Yes, sir.
Yeah.
Can't see.
You can't see? Wait, is anyone else having that problem? Something. Is anyone else having that problem? They can't see.
No, sir.
Anisha, I don't know what's going on with your device. Try rejoining if you notice something like that happens, right?
Okay, sir.
Yeah, because it happens to me during classes as well. Everyone else was singing and I wasn't, so I just rejoined and it don't seem to fix it. So you could try that. All right, so yes, as I was saying, the last time we went through the distributive law, and from factorization, now that I've went through factorization before, you'll notice that, and I identified this. What? Yeah, and I identified this was that factorization is basically you're going backwards in terms of the distributive law. So the distributive law would show you how to open out the brackets, right? Is the mathematical law governing how you open out your brackets to get back the original expression, right? Factorization is just re-expressing the expression in simpler terms using their factors, right? Using the highest common factor. Now we went through a lot of examples with the distributive law. Do not forget how to identify. Take your time, do the numbers first, highest common factor among the numbers, then go for the variables, and of course, common variables is just use the one with the highest power, right? Now, here's where we left off. I said last class we do an exercise where you guys tried the factorization because I did multiple examples already. So you guys are going to do these 7 questions. Number 6 and 7 I know look very but I did teach you a strategy to use with the fractions. Let's see if you remember. And we'll complete this. I'm going to give you guys about 15 minutes. We'll complete this and then I'm going to move on to factoring by grouping, which is simple. Honestly, it's simple as the honestly it's simple as using highest common factor and distributive value. As soon as once you get those concepts down, the others won't look too hard, right? It's just adding on something that you need, something else that you need to remember, right? So let me stop the recording. You guys can start this exercise. Again, 15 minutes. Yikes. All right, start the recording a bit late there. Yeah, so 9x squared open bracket 9 minus x. Close this the answer for now. Thank you, Rihanna. Anybody have a problem with this answer? The expression in the bracket, Denisha.
Sir, the highest common factor is x.
Then
Open bracket 2x. Take 9, close bracket.
all right, you're breaking up, but I got you. All right, so x open bracket 2x minus 9, right? This is the answer we got for the second question. Anybody got a problem with this? But I'm using the class to double check the answers.
Highest common factor is 5.
5, just 5?
XY.
5xy.
Bracket 3x. Negative 2y over 2.
Negative 2y minus 2y. Is it?
Square, sorry.
Square. Y is squared. All right. All right, so we are in agreement with this answer. 5xy open bracket 3x minus 2y squared. Any disputes here?
Sir, I didn't make so far. When I get it, then let me know.
All right, well, do the problem now. I will come back to it. Right for you. Do the question now, we'll come back to you, right? All right. Same people. Back to you, Denisha. We're just doing a full rotation. Back to Denisha. What the highest common factor for this expression?
Sir, negative 8.
Use a negative 8. All right. Negative 8.
Plus open bracket. No,
You
t.
said
Negative 8t.
open bracket. Yeah, let's go.
So negative 8. Open bracket x plus 2y plus 2y
I got it 2y.
plus 3z
Plus 3z.
3z plus 3z. So
Yeah, that's my bad. I heard you, but my brain wrote the wrong thing. Good. All right. And you guys a break. I'm gonna do this one. And for these fractions is the same thing as I said before. If you're dealing with fractions, your fractions, multiple fractions. Actually, once you're dealing with fractions and you want to factorize fraction expressions, algebraic fractions, the simplest way to do it is to just use your use fractions, right? So first thing I'm going to do is put my division sign, right? The division, and then I'm going to factorize the numerators. So I'm imagining it like this, right? The usual way we're factorizing all the time. I'm imagining it like this with the numerators, and then I'm going to come to the bottom and factorize the denominators. Right, so for the highest common factor, I'm going to try and come with the highest common factor in the numerator, and then I'm going to come with the highest common factor in the denominator. You do that, and you'll be fine, right? So r square, right? R square, r to the third point, r to the fourth power. We know amongst variables, if we're factorizing variables of the same kind, we just take the one with the lowest power. So r square is part of our highest common factor. Then we have s. S is in all three terms. S to the fourth, and s to the fifth. The one with the lowest power is just s. And q is only in the last term over here. So the highest common factor, at least for the numerators, is r square s, right? Coming down to the denominators, we have numbers now. So 9, 3, and 27. The highest common factors right away you should be able to see is 3. The highest common factor number, right, would be 3. Next we have p to the third, and p square. Let's double check it. So yeah, next we have 9p, no, p to the third, and p square. Of course, again, once you're dealing with the variables, just take the one of the lowest power, provided that the variable is in each term, right? That's what we need to check for. So it's in each term, the lowest power is 1, so p. Right, so the highest common factor here is r square s divided by 3p, open bracket. Then you have to divide these two terms. Now the quickest way to you can't go in a corner and divide them, meaning that you put the division sign between the two fractions, flip to the right hand side, and see how things cancel out. Or again, you can think of it as factorizing numerators and denominators. So divide numerator by numerator and denominator by denominator. When you flip the fraction, that's exactly what happens, right? When I do this, right, because right, we're dividing these two terms, right? We are dividing two algebraic fractions. So r square s, 9p, divided by r square s, 3p, divided by 3p. Right, and we know how to divide fractions. We just flip the fraction on the right hand side, and change the sign to multiplication, right? So r square s, 9p multiplied by 3p divided by r square s, right? And you notice right away r square s goes away r square s because you're dividing. If you don't see it like that, we can go ahead and multiply across. Yeah, we can go ahead and multiply across, meaning that we can get our r square s 3p at the top. We multiply straight across, and 9p r square s, right? And you see s goes out with s, r square goes out with r square, p goes out with p, and 3 over 9. We're left with 3 over 9. In other words, 1/3, right? If we reduce our fractions, we're left with 1/3. So all of this divided by this will just leave us with 1/3. So you can go ahead and do it the normal way. However, this will take time, right? Because you got to do this for each fraction, right? And the alternative that I'm offering is that you divide numerator by numerator, because when you flip, that's essentially what's happening. R square s is dividing by r square s, right? You end up dividing the r square s by r square s. So you are still dividing the numerator by numerator and denominator by denominator. So the same thing, right? Do the numerator first, then the denominator, right? We got the highest common factor. Next, let's get the bracket expression. So r square s divided by r square s. Anything divided by itself is 1, right? Any expression, I should say, not anything. Any expression divided by itself is 1. So 1 right away. Now 9p divided by 3p, of course, p and p will cancel each other out, and 9 divided by 3 is 3, right? So we got 1/3 without having to do all of this. Is everybody following so far? Because so we have to divide the two. Again, divide numerator by numerator. So r squared divided by r to the third, r cubed, let me say cube instead of to the third power, r cubed s to the fourth divided by r square s. Again, all this is laws of indices, which we will cover a bit later. But the basic thing about laws of indices is when you're dividing these variables, right, by each other, they just decrease you just have to decrease the power, right? So r square r squared divided by r to the third power divided by r squared, we just leave you with r and s to the fourth power divided by s. We just leave you with s to the third power, right? And if you're not seeing this, r squared s, right? This is just a shortcut way of doing it. But if you're not seeing it, r to the third power is 3 r's multiplying each other. S to the fourth power is 4s multiplying each other. So you can go ahead and see it like this. So r times r times r. This is r to the third power. And s times s times s. This, of course, is multiplication. Times s. This is r to the s to the fourth power. Then we have r times r at the bottom. R squared. Then we have s, right? So I've written them out so you can see exactly how I ended up with, exactly how just subtracting the powers gives you the answer, because 3 minus 2 is, 3 minus 2 is 1, and so you just end up with r, and 4 minus 1, s doesn't have a power, so the power is 1, that's understood. So 4 minus 1 is 3. All right, so r to the r s cubed. Now coming over here to the division, again, anything divided by itself will just cancel out or give you 1. So r and r goes out with 2 of these r's. So you see, you just end up with the 1r on top. And then s goes out with 1 of these s's. So you just have back with 3s multiplying each other. And 3s multiplying each other is s to the third power. Right, so we just end up with s to the third power, which is exactly what we have here, r s to the third power. Right, we do the same thing over here, 3p cubed divided by 3p, same thing. 1, this 3 divided by 3 is 1, so those two cancel out. The 3's will cancel out each other. But p to the third divided by p will just leave you with p squared. Again, you just need to minus the powers, right? 3 minus 1 is 2, right? So p squared. Next is r to the fourth s. Yeah, the next term, we're going to the next expression, dividing it by our highest common factor, right? So r to the fourth power s to the fifth cubed divided by 27p squared, right? Dividing that by our highest common factor. Again, numerator by numerator, denominator, denominator. Should get the answer there. So again, minus the powers. So r to the fourth divided by r squared, we just leave you with r squared. And s to the fifth divided by s, we just leave you with s to the fourth. You just need to minus the powers. And q, we don't have anything to divide by q, so q just comes back. Right? Coming down to the denominators, 27p squared divided by 3p. 27 divided by 3 is 9. And p squared divided by p. Just subtract the powers when you're dividing these like variables. P squared divided by p will just leave us with p. Okay, my 9 looks like a cube. This is a 9. This is p. And that is the answer. Any queries there? Number 4, let me hear the answer. Is the only highest common factor between these numbers are 1, right? Only 1. Right? 1 is the highest, 1. Because I don't think this number should be, I think this number should have been 24 instead of 4, but can't change that now. So it's 1. So the numbers would just give you 1, but you still need to factorize the variables next, right? And we know we look for the common variables in each term and take the power of the lowest one, right? So 9, 36, and 4 will just give us 1. You can put a 1, or you can go ahead and factorize the variable, because 1a is the same as a, that's just a. So a is the common variable in all 3 terms. So the highest common factor would just be a. And you would just end up with negative 9b plus 36c. This is not the, again, this isn't the actual life. I have a strong feeling this should have been 24. I do believe that should have been 24, right? But this would be the answer, right? You can't do anything more than this. But how about this? Yeah, we'll change it up and just erase the problem child, right? The term was the problem child, so we erase the problem child, and let's factorize this in a 9 what? Because I can hear something.
9A, sir.
9AC?
Yeah.
That's your final answer? 9AC? Oh yeah, C is not in both terms. So why is C being factorized in the highest common factor? C needs to be in both terms for you to factorize C. A is in both terms, so we can factorize. That's the first thing you check for. Once the variable is in both terms, only then it comes in the highest common factor. If not, it's not, right? So B is not in both terms, so it stays. C is not in both terms, so it stays. So it's just 9A, right? And then we would go ahead and divide negative 9AB divided by 9A, which just leaves you with the minus B, because the 9 and A will just cancel each other out. And divide the other term, we end up with 9A open bracket negative B plus 4C. Right. The last problem is question 7. Now I explained how to do this. Not going to do that again. Right. I explained how to do this one. Yeah, I explained how to do number 7. Given what I just said, you guys can try this one, right? Try this one, given all that I just said. With number 6, try. So I want the rest of the class to try before we go through the answer. But it's about 418. Those are the problems. We'll go through the last one once you guys have tried the number 7. We're not going to be learning anything that new with factoring by grouping. So let's go ahead. Now, factorization by group or by grouping is you're just grouping the terms, right? So factoring algebraic expressions by grouping is typically applied when you're given at least 4 terms, right? Remember this, you can only factor by grouping if you have 4 terms. You should only factor by grouping if you have 4 terms. So far, we've looked at factorization, and we'll come back to that just now. If so far you notice that we looked at factorization with 2 terms, so 1, 2 terms, and we've also looked at factorization with 3 terms, but never a 4th term, right? At least not yet. So what happens if there's a 4th term? There's another method to use if you add another term. We're not going to factorize the normal way we've been factorizing, where we just go ahead and get the highest common factor and then divide. We're going to do an extra step. Right? We're going to do an extra step where we group them, right? I says it's factorization by grouping. So you need at least 4 terms to group. And in these situations, factorization is done by pairing the terms in such a way that they share at least 1 common factor, right? We don't have a highest common factor if we don't have common factors. So once we're grouping it, we're going to look to ensure that there is at least 1 common factor. But what really you need to pay attention to is not factor. The factor is actually a variable, so it needs to have at least 1 common variable. So when you group 2 terms together, they have to have at least a common variable, right? they need to have a common variable for you to, or common factor. Doesn't necessarily have to be a variable, but in most cases you will see a common variable between in your peers or in your groups, right? So when pairing or grouping, the terms must have at least one common variable, and I said that back here, right? So common factor or variable, right? Either one, same. But I will show you guys what happens when you don't do that. So you'll see what happens when you don't do that. So the first example, like before, I will go through a lot of examples so that you guys get the concept and give you guys exercise questions to do. You guys practice yourself, and then we move on to the last few factorization methods. That's how we're going to go through these. Good. So we have the first expression. Again, you notice 1, 2, 3, 4 terms. Think factorization by grouping. I'm trying to instill this in your this thought pattern in your head already, right? You have 1, 2, 3, 4 terms. Think factorization by grouping. Don't try factorizing the way we did before. Try factorizing by grouping first. Usually that's what they expect you to do, right? Factorizing by grouping. And we will go through C-set questions. Next class, I will go through some C-set questions with you guys, and you guys will see how easy it is. The C-set questions are compared to what I've been giving you. So look at Px plus Py. There is one that is very difficult. There is one that is hard, but those are the old questions. So the first example we're going through, it's Px plus Py plus Qx plus Qy. Now, the first step with factorization by grouping is to group them. That's the first step for factorization by grouping, is to group each term, is to group them into pairs of 2. Right, so the first thing I do is group. I'm not even trying to write it. All right, the first thing I do is try and group, well, not try, group them in pairs, right? Right, by them, I'm referring to the terms in pairs, and pairs mean 2, right? 2 terms, right, in pairs or in couples. None of that more than. But so I have them in 2 pairs, and then you factorize the normal way. So we come over here, the first pair is Px plus Py. Now the thing about the pairs, they must have a common factor or common variable, at least one common variable. So in this pair we have Px and Py, Px plus Py, and the common variable here is P. So we checked off the fact. So this pair is green light, right? This, you can check this off, right? Next, we come over to the second pair, check, ensure you have 2 common terms or 2 common factors in both terms, right? So Q is in both terms. It means we can factorize properly. They are also checked off, green light. So we got 2 green lights. We can go ahead and factorize by grouping, right? At least the 2 groups work, right? So we have Px plus Py, factorize like how you would normally factorize, right? We don't have any numbers, so no need to factorize by numbers. So the highest common factor here would just be P, right? P and P is in both terms. Take the one of the lowest, the one in the lowest power. There is no power other than higher than 1, so just P. And X and Y is not, X is not in both terms, Y is not in both terms. So the highest common factor within this group is just P, right? Then we go ahead and divide. Px divided by P is just X, just leave us with X, plus the Py divided by P. We just leave us with Y. So we end up with P open bracket X plus Y. That's the factorization using the highest common factor in distributive law for this first pair. Then we go to the next one. We do the same thing, right? So Qx plus Qy. Now the highest common factor is Q, but what you do here now, you're just not going to write Q. You need to specify whether it's plus Q or negative Q. Before this the highest common factor was at the end here, so you didn't need to put the sign. But here you do need to put the sign for the highest common factor. If it's plus, you need to put the plus because this expression is adding or subtracting the other expression, right? It's still an expression. It's still one complete expression, right? So you need to add the plus or minus, whichever highest common factor you want to use, right? Remember, you can use either one. In this case, I will show you that which one to use because sometimes using the positives all the time doesn't work. So qx plus py, you just need to divide the highest common factor is q. Qx divided by q is just x. Qy divided by q would just be plus y, right? So one thing you'll notice right away, at least it should start jumping at you, is that we end up with one thing that should jump at you right away is that we end up with two expressions in brackets that are the same. If you're factorizing by grouping and this doesn't happen, it means you did something wrong. That's one of the things about factorizing by grouping that you need to remember. If your brackets, if when you factorize and the terms in the brackets are not the same, then you did something wrong, right? Or you can't factorize by grouping. Not necessarily you do something wrong. It's just the factorization by grouping doesn't work, right? At least the next few following steps wouldn't, right? So this is the first thing you'll notice, that you end up with the bracket term being the same for both of your pairs, right? So x plus y over here and x plus y over here, right? That usually happens once you're factorizing by grouping, right? So the next step is just to, first thing, you some teachers do it differently than the way I'm about to show you. But the answer is still the same thing, even though they might tell you something different. So don't worry about that. The answer is still the same. So the first thing to do is write back the term in bracket, the common term in bracket, which is x plus y, and then write the terms outside. So the terms outside is p plus y, p plus q, sorry. So p plus q, p plus q, close bracket. So you write the term that's in both the common, this is actually a factor. So the common factor in both, you write that back and then you put the bracket, the terms outside, which is p and the plus q, right? So p plus q. Take the sign of the, please make sure you take the sign of this highest common factor. It's plus q, so that plus comes back between, plus comes between the p and the q, right? Don't just put p, q, right? So that is it. Any questions? That's factorizing by grouping. I'm going to go through some more examples, but I want to know if there are any questions. All right. Be prepared for the next session to swallow a lot of information, but generally, as you see with this by grouping method, you're just grouping it, factorizing it as normal, seeing that you have the same bracket expression in both of your paired factorized form for both of your pairs, and just putting them together to give you one expression, right? And it's simple as just taking the two, right? Just taking the common bracket expression, and then you create a new bracket expression using the terms outside. It's as simple as that. We will go through more examples. However, that's time